Hey guys, in this video you're going to learn how to create your own YOLO version 5 dataset, and you're going to do that using the darknet format. This will be part of videos in which we're going to create our own dataset, then we're going to fine-tune YOLO version 5 model and deploy all of it into production. Let's get started. For the purposes of our tutorial, we're going to take this dataset, which is provided at Kaggle, and the name of it is Clothing Item Detection for E-commerce. And this one is provided by Dataset, and you can see that this one is relatively old. 2018 is the year that this one was submitted. And you can go to the Dataset website and you can see that we have 907 items, and some of those were manually labeled, and we have in total 9 categories, and you can probably guess that those categories represent some kind of clothing. And well, we are going to use this, for example this one, images like this one, to create a dataset which is going to be compatible with YOLO version 5. YOLO version 5 was publicly open sourced about 2 weeks ago, so this is a very new project, and the source code is available on GitHub. It is done by a company called Ultralytics or something like that. And the GitHub repo contains a lot of documentation, a lot of examples, and a benchmark about the model. And in this video, we're going to just focus on the tutorial right here, which is going to be train custom data. And I have that opened up right here. And this basically walks you through the process of which you have to convert a given data set into the darknet format. And it's very well explained right here. At this particular video, we're going to focus on creating the dataset itself. So this one is going to take some form of labels and images, and I'm going to show you how you can basically recreate all of this for our own custom dataset. The dataset that is available on Kaggle is just a single JSON file, and if you go here, you can see that file right here. So you can go ahead and download this, but I've done something a bit better. I've already uploaded this file into my Google Drive, so you'll be able to reproduce the steps of this tutorial very easily. And here we have an empty Google Colab notebook, and here I'm going to download this JSON file. I'm going to use gdown for that. I'm going to paste in the ID along with the command, and I'm going to run this. This will have to connect to the runtime, and here I'm using no hardware accelerator because we don't need one to create or build our own dataset. So you can see that this is actually downloading this file called clothing.json, and this is the whole dataset. So let's start with some imports which we are going to need in order to explore this dataset. And I'm just going to copy and paste the imports that we're going to use. So most notably, we're using patlib. We actually don't need this one, I guess. We're going to import URL-lib because we are going to download some images. We are going to use OpenCV for image transformations. And we are basically setting up our plotting libraries right here. So let me execute this one. And next we are going to read the annotations that are available into this JSON file that we've downloaded. So for that, I'm going to create an array, and this array we're going to fill every line of the JSON file that we have, because this JSON file is actually every line contains an object. So we are going to open the file, And for each line into of this file, we are going to load the JSON contents of this line. And we're going to append the result to the array that we've created. So I'm going to do json.loads line. And once this is complete, well, I have an error right here. So once this is complete, we are going to have a look at how many examples do we have here. So we have 504, which is exactly the number that we had right here. So this is pretty much working as expected. Next, let's see what a single annotation looks like. And I'm going to have a look at the first one. So here we have image height, image width, we have a label, we have some notes, which is some text, and we have the points, and those points are XY and XY, so a tuple of XY and XY, or a tuple of points. And you can clearly see that these points are not in pixels, they're just relative percentages, so they're between 0 and 1, and they're based on the image height and the image width. And this is going to be some sort of an issue when we are going to pre-process or post-process this data, but we are going to have to handle it. And finally, we have this link to the image, and if you open, for example, this one, you can see that this is opening an image in S3 of the example that we are looking at. So we have an URL to the image, and we have the annotations or the bounding boxes which we are going to need for the object detection right here. All right. So another thing that we are basically going to know about is whether or not we have multiple annotations per image, because you can see that here we have an array of annotations. So to do that, I'm going to loop over the annotations, and if the length of the annotations is larger than 1, I'm going to simply display the whole quoting annotation. And we have just a single example, but single example is enough, so we'll have to handle it. We have a single example with this image, which contains basically two labels. One is jackets and the other is skirts. So there is jacket somewhere around here, I guess. All right, so we are going to write our annotation preprocessor to be a bit more robust based on this information. Next, we are going to get a list of all available categories, because we are going to need that to create the darknet format annotations. So to do that, I'm going to create an array called all categories, or let's say just it's categories. And here I'm going to loop over all annotations, and I'm going to loop over all annotations into the coding examples. And I'm going to extend the categories with the labels for each annotations, because here you can see that the labels are actually an array. So we are adding all of those right here. And then I'm going to get the unique values . So I had some sort of hiccup right there. So I'm going to pass in the categories, and then I'm going to convert this set into a list. And I'm finally going to display all of the categories that we have. So we have jackets, sunglasses, tops, shoes, skirts, trousers, etc., etc. So we have all of the 9 categories, and we're going to check that by getting the length of it. Yeah, we have the 9 categories. So we have the categories, and now we are going to split our dataset into training and validation set. So to do that, I'm going to use the train test split from SKUlearn, and I'm going to create train coding and validation coding. Split this passing all of the annotations, and I'm going to reserve only 10% of the data for validation. So this is not defined, so I'm going over here and I'm going to import from SKUlearn model selection, import train test split. All right, execute this, and I'm going to go down here, run this again, and this should be running. And now I'm going to have a look at how many examples do we have into the training and the validation sets. So we have 453 examples into the training and roughly 50 examples into our validation set. So this is pretty good, but note that we have a very little data, and we are going to see how well YOLO version 5 is going to handle this very small dataset into the next video. All right, so recall that we need to get this image basically from S3, and we are going to have to save it on our hard drive, at least into this Google Colab machine. So to do that, I'm going to create or get a single annotation. And if I run this, you're going to see again the contents of this annotation. And I'm going to take the image or download it using URL lib request URL open. And I'm going to take the content, which is going to be this URL right here. Next, I'm going to use the PIL image to open the contents of this byte data, and I'm going to convert this into RGB format. Finally, I'm going to save this demo image into JPEG format. And I'm mixing the casing here. Not exactly, but yeah. So you can see that we have this image right here, and if you open it, this is the image. So this looks very well or very good. We have the image on our local machine or cloud machine. And next I'm going to use OpenCV to read the image, demo image JPEG, and recall that I need to convert this into the RGB format because OpenCV is really crappy like that. All right. So this image is now a NumPy array, actually. You can see that, and you can get the shape of it, for example. Yeah, we have the width, the height, and the number of color channels right here in this array. So next I'm going to create or apply the annotations for this image. And I'm going to do that by iterating over all annotations and all labels. And right here, I can get the width of the image, which is going to be stored. Let me just print the row right here. So I'm going to take from the annotation, I'm going to take the image height and the image width. So I'm going to start with the width. for the annotation image width, and Google Colab is nice enough to understand the structure of this dictionary. And then I'm going to take the image height. So we have the width and the height, and we are going to basically need those because again, the point coordinates are normalized into values between 0 and 1. So next I'm going to take the points. And I'm going to take the first and the second point because we have array of points. And next I'm going to take the x1, y1 from those points, but I'm going to apply the width and the height. So we are going to get real pixel coordinates based on the image width and the image height of this image. So I'm going to do p1x. So I'm going to point at this value right here, and I'm going to multiply that by the width. So I'm basically multiplying this by the width. Okay, so next we have p1y, so this value right here, and I'm multiplying this by the height to get again pixel values of those points and those coordinates. So I'm going to do the same thing for the next point, p2. All right, so we are basically ready to draw the label, the annotation rectangle, and I'm going to do that using cv.rectangle. And right here, I'm going to pass in the image. I'm going to pass in the first point, and I'm going to convert this into an int, and I'm going to pass in the second, the y point actually. And I'm going to do that for the second point as well. I'm going to apply a color, which is going to be with RGB values, 3 colors for each red, green, and blue. And we're going to specify 0 for red, 255 or maximum color for green, and 0 for blue. And then I'm going to apply a thickness, which is going to apply the thickness to the border of this rectangle that we have right here. So if I run this, I expect to don't give us any output, but the result of this is going to be this image right here. All right, let me zoom out this, and you can see that we have the image along with the annotation of it, which is pretty good. And just to make sure that this is actually doing the work, I'm going to read the image again, not apply this cell, run this one, and you can see that we are just getting the image without the annotation. So this one is working very well, but something is missing from this annotation, and the bounding box is here, but we don't see the label of the annotation. So I'm going to apply that to the annotation as well. To do that, I'm going to start by getting the text size, which we are going to apply over the annotation. And the text is going to be this label right here, which we are currently not using. And I'm going to pass in to call the cv.getTextSize. And this one takes a lot of parameters, but we are interested in supplying the text itself or the label. In our case, we are going to specify font face, which is going to be font Hershey plain. We are going to specify the font scale, which is basically how big the text is going to be, and the thickness of the text. So this returns a tuple of 2 values, of course, and the first value is actually another tuple, and we are basically interested in this first value. So I'm going to extract the information using something like this: label width and label height. So this gives us the label height and label width of this example or this text. So using that, I'm going to start with a background. I'm going to basically draw a green background somewhere right here, and on top of this green background, I'm going to write into white, using white letters, the label itself. So let's start by drawing this rectangle background for the label. I'm going to pass in the image, and I'm basically going to take those values, except that we are going to do some changes. For the thickness, I'm going to say that we want this rectangle to be filled, and for the second point, I'm going to add the label width to the first point, and then I'm going to basically add some padding, which is going to be around 5% of the width. And for the second point, I want to, let me actually do this. It might be a bit clearer. All right, for the second point, I'm going to add to the first point the label height, similar to the point above. And again, I'm going to add some padding, but this time we are going to add around 25% of the padding of the label height. So if I read this image again, run through this and show the resulting image, you can see that we have this rectangle right here. So this is placed perfectly. And finally, we need to do we need to basically show the text right here. So to do that, I'm going to use cv2.putText, and I'm going to apply this over the image. I'm going to write out the label, and this next thing is the point of the origin, which is basically bottom left. So this is bottom left point of the text. So here I'm going to pass in x1, and I'm going to pass in y1. Then I'm going to apply the label height because we want to go to the bottom, and I'm going to apply the same padding, so our label will be all the way to the bottom of this. All right, so now that we have the point at which the text is going to be written, I'm going to specify the font face, which is the same font that we are using for the getting of the text size. This is really important because the text size won't be accurate, or the result of the font text, the text size won't be accurate. And I'm going to specify the same scale. And for color, we are going to go all white. And the thickness is going to be 2. So if I run this, you can see that we have the class name or the label right here on this background. Now that we have some intuition about the dataset and the annotations that we have so far, we are going to convert or adapt this dataset to YOLO format or the darknet format. So what are the requirements? You can go to this train custom data wiki tutorial, which is provided by the Ultralytics, and you can clearly see that we are going to be required to create a text file which is going to contain the labels for each image that we have. And in this text file, we are going to have the class or the category of this object. We have the X center and Y center of the bounding box. And the bounding box is this thing right here. This with the green borders. And then we have the width and the height of the bounding box. But you can see that we are required to have normalized values. So this one actually requires our numbers to be between 0 and 1. And here is an example of organization of the folders that are required for the model to run. So I'm going to basically create a single function that does everything for us, including downloading of the images and creating the labels. But to do that, I'm going to basically paste a hint of what we are going to do. And this will be available, of course, into the notebook that you're going to receive once this tutorial is complete. Of course, free of charge. So this one is a bit more understandable, at least for me. So we need the class index in each row of this text file or the labels. We have the class index, we have the bounding box center of the X value, we have the bounding box center Y value of the point, we have the bounding box width and the bounding box height. And the bounding box coordinates must be normalized between 0 and 1. So to do everything, we are going to use this function that we're going to create, which is going to be named appropriately create dataset. And here we are going to pass in the annotations, the coding annotations, and then the dataset type. Remember that we are going to create two datasets. First one is going to be for training, and the next one we are going to use for validation. So right here, I'm going to start by specifying a path for the dataset of the images, I guess. So I'm going to call this dataset images. And here I'm going to specify clothing images, and then I'm going to pass in the dataset type. I'm going to make sure that dataset images exists, and this will go ahead and create all of the necessary folders if any of those doesn't exist, and if those exist, it's going to do nothing. So next I'm going to do the labels. So let me rename this into images path and labels path, coding labels, and pretty much the same thing, dataset type. For the labels path, I'm going to basically copy and paste the same insurance for that our directories are available for us. So next I'm going to iterate over the annotations in the coding, and for that I'm going to use the index as an image ID, and I'm going to get the annotation into this row variable, and here I'm going to use tqdm to follow the progress of this enumeration. First I'm going to start by creating an image name for this, and I'm going to use the image id.jpg. Next I'm going to download the image, which is really similar to what we've already did. I'm going to get the content of this. I'm going to open the image, and I'm going to convert it into RGB format. Next I'm going to save this into images path, and I'm going to pass in the image name. So we are going to use the magic of the overloaded methods right here. So this will be a valid Python code. And I'm going to save this into using a JPEG compression. Next, we are going to specify the label name of the file, and I'm going to again use image ID and .text. So in this text file, we are going to write out the annotations for this image, or the bounding boxes and the classes. So right here, I'm going to use the label spot and the label, let's say that this is label file actually. All right. And I'm going to open this in mode for writing. All right. So I can see label name. Let's revert this. And I'm going to use this as label file. So for each annotation into the annotations, and for each label right here, I'm going to take the category index by using the all category, the categories that we had, and I'm going to take the index of that category. Next, I'm going to take the points which we've already did somewhere here. I'm going to take all of this. I'm going to paste it right here. I'm going to fix the indentation, and I'm going to remove the multiplication by width and height, because darknet requires us to have those into 0 to 1 normalized coordinates. And I'm going to calculate the bounding box width by subtracting the value of x2, the value of x1 from x2. And for the height, I'm going to do exactly the same thing using the y values. And finally, I'm going to write into category index. I'm going to write out the x1 center point for the bounding box for the x value. So I'm going to take x1 and I'm going to add to that half of the width. Next, let me just do this. Next, I'm going to do the same thing for the y values, but I'm going to use the height and take half of that. Next, I want to specify the bounding box width. The bounding box height. And finally, I'm going to add a new line right here. So we have the category. Let me just double check this. We have the class index or the category index. We have the bounding box x center. We have the bounding box y center point. So x center, y center, and then we have the bounding box width and height. And those are normalized between 0 and 1 because our dataset has already done this for us. All right, so let me just continue by calling this function on the training dataset, and we are going to do the same thing for the validation dataset. And let me just open up this and start running. So Makadir got an unexpected keyword argument parent. So it's parent. All right. If I execute this and run this, you can see that the process has started. So this took about a minute to complete, and you can see that right here we have this coding. directory, we have the images and the labels. And if you open up those, you can see that we have the train and validations and train and validations. So let's just start or continue with exploring the structure. I'm using this tree command, which we need to install. And this will basically give us a nicer representation of the structure for 2 levels deep. And we have the calling, we have the images, the labels, exactly what we've seen right here. And we have train and validation for each of those. So finally, I'm going to get a look at, let's say, the labels for the first training example that we have. And this is the example. So we have a category index of 4. We have the next values which represent the center of the bounding box, and we have the bounding box width and height, and all of this is in normalized values that are required to be between 0 and 1. Now you have a complete darknet compatible dataset, and you can go ahead and try out this dataset using the YOLO v5 project, or you can wait for the next video in which I'm going to show you how you can do some transfer learning or fine-tuning with YOLO v5 using the dataset that we've just created. So guys, please like, share and subscribe if you like this video, and I'll see you in the next one. Bye bye.